This video is to go over how to factor a quadratic when it's the difference of squares. So typically when we factor a quadratic where a is 1, so it looks like the form ax squared plus bx plus c, we're always looking to see what would multiply to be c and what would add to be b. In this scenario, we don't have a b value. So if I'm looking at number 1 here, I really have x squared plus 0x minus 36. So if we're trying to figure out what multiplies to be negative 36 and adds to be 0, it would need to be a pair of opposites. And so if I'm thinking, okay, well, what multiplies to be 36? Well, 1 times 36, but if I make one of these negative, it's not going to cancel the other out. But if I use 6 and negative 6, it would multiply to be negative 36 and add to be 0. And so then my two factors would be x plus 6 and x minus 6. So in this situation, we're always going to have perfect squares. So it's important to have some knowledge, some foundational knowledge on your perfect squares. And so I've listed those out here 1 through 12. If you want to pause and jot that down. But I recommend kind of knowing 1 through 12 and then being able to get 1 through 20 kind of quickly, and listing them out is always helpful for these. All right, so if I'm dealing with the same exact setup and I look here, I'm like, okay, well, x squared is a perfect square because x times x is x squared. And 121 is a perfect square because 11 times 11 is 121. Because there's that minus sign in the middle, I know I would need opposite signs to multiply to be a negative, and because of those opposite signs, if I add 11x and negative 11x in the middle, it would cancel out. So that's why there's no b value, and so this works every time. Now, sometimes the difference of squares might be hidden behind a GCF or something like number 3 where there's a negative x squared. And so anytime we have a negative x squared, we're always going to want to start by factoring out a negative 1 at least. And so here I could take out a negative 1, and that would leave me with positive x squared and negative 100, because 100 divided by negative 1 is negative 100. Now I have the difference meaning minus in the middle, of squares, because 100 is a perfect square and so is x squared. So I'm going to rewrite my final answer as x plus 10 and x minus 10, since 10 times 10 is 100. And you don't need the 1, you could just have the minus sign in front. All right, another situation is when both the x squared has a number and the constant, they're both perfect squares. And so here I have 9x squared, so 3x times 3x is 9x, and 5 times 5 is 25, and there is a minus sign in the middle. So I can set this one up as 3x plus 5 and 3x minus 5, because 3x times 3x again is that 9x squared, and 5 times 5 is 25. Sometimes it might be written backwards, and that's okay. I'm going to show you the two different ways that you might see answers come up from this setup. So if I have 81 minus 4x squared, 81 is 9 times 9, 4 is 2 times 2, x squared is x times x. They're all perfect squares. Then I could just simply write this as 9, because that's the square root of 81, minus 2x squared or plus 2x squared, doesn't matter which one you put first. And then 9 minus 2x squared. So again, if you flip-flopped these parentheses, that's no big deal. It's equivalent. Both are equally correct. So that's one way you can see your answer choice show up on, say, like a multiple choice exam. Another way that you might see this written is for the problem to be flipped around, and then the negative sign be factored out. And so now I could write my answer as minus 2x plus 9 and 2x minus 9. So either of those are equivalent. They're all different forms of the original quadratic. All right, my last example here is when it can be very sneaky that it's the difference of squares, because on first glance of number 6, you might think 8's not a perfect square, 98's not a perfect square, and you're right. But it's hidden behind a GCF. And a GCF is a greatest common factor. It's a number that can go into both numbers. And so 8 can be divided by 2, and so can 98. And so I can factor out a GCF of 2. Let me go in a different color. And so when I take out a 2, I'm left with 4x squared. I just divided 8 by 2. And if I divide 98 by 2, I'm left with 49. Now, 4x squared is a perfect square, and 49 is a perfect square. So I have 2x, because 2x times 2x is 4x squared, plus 7, because 7 times 7 is 49, and then I will write it with the minus sign. So our general kind of formula, I guess, if you wanted a formula, or I think I'd rather call it just a rule, is if we have something like x squared minus y squared, then we can say that we're always going to do x plus y, x minus y. So we just take the square roots of these perfect squares right here.